Consider a population of 250 with a mean of 55 and a standard deviation equal to 23. What is the probability of obtaining a sample mean of 57 or less from a sample of 35? Okay, let's look at this. So this is a new concept that we haven't looked at. When the population is small, the proportion of the sample size to the population size can be large. So the proportion of n to n. Remember, the big N is the population size. So here, our sample size is 35 and our population size is 250. So if this proportion is greater than 5%, and let's see what it is, do 35 divided by 250, and you're going to get 0.14, which is 14%. So if you get greater than 5%, which we do, and when we get that, we're going to have to use a formula, a formula that includes what we call a finite population correction factor. So you're going to do your standard error of your mean, which is the standard deviation over the square root of n, but you're going to add this extra piece that is known as the finite population correction factor. So it's adjusting for this small population. So we're going to plug in everything here. So first you have to test it, and then if it's greater than 5%, you have to add this piece to it. So we're going to do 23 over the square root of n, which is 35, times 250 minus 35, the square root of 250 minus 35, divided by 250 minus 1. So first of all, let's simplify this part here. 215 divided by 249. And let's see how we're going to round on this. I don't think it will really affect it too much, and it's probably make an adjustment so that either answer is acceptable. So here's where they're starting to work it, and it looks like they rounded to 2 decimal places. So what I would do is I would do 215 divided by 249 and take the square root of that, or just take the square root of 215 divided by 249 and close the parenthesis. And if you don't have a calculator that can do that, you can actually take the square root in Excel. All right, and you're going to get like 0.929222156. So you're going to take that and multiply it by 23 divided by the square root of 35. And you're going to get 3.61. Okay, so we've done that. Now, that took a little bit longer. But now we have everything we need to calculate our z-score. And I'm going to move that down because I don't expect you to learn any of these formulas. What you need to practice is knowing when to use what. That's the hardest part about this class, is knowing what formula to use. Okay, so And I believe after we get the z-score, we're going to look it up in Excel. Okay, so our sample mean that we're looking for in this whole problem is 57. So 57 minus the mean of the sample means, which is 55, divided by the standard error of the mean with the finite population correction factor. So you get 0.55. So let's look up the probability. So we're going to do norm.dist, and we got the z-score, so we're going to do norm.s.dist, and we got a z-score of 0.55, and we do want it to be cumulative, so we want that to be true. So you will get 0.7088. And let's check that. 0.70088 is correct. So that is how you use the finite population correction factor. Let me know if you have any questions.